Hey everybody, this is Larry. This is me doing an extra bonus premium problem that I have not solved yet. 1650, lowest common ancestor binary tree 3. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So yeah, I did get a request on the Discords about this problem, and I'm procrastinating on packing for my trip, honestly. So I figured, yeah, let me just kind of do an extra one. I haven't done an extra bonus problem in a while, so I'm trying to get my premiums worth as well. So yeah, so let's take a look. So today we have this problem. We got given P and Q, return the lowest common ancestor, LCA. So this should be pretty straightforward. Let's see if there are any additional constraints. N is pretty big, but there's nothing to be said that you cannot, walk both nodes, right? There's a couple of ways you can think about this. You could walk a node at a time and then see which one is, if you've seen. So yeah, there are, if there's a lot of literature about this, right? Basically, if you want to pre-process the array so that, or the tree, such that you could keep on looking at all the nodes, so you could query LCAs on all the nodes, there are a lot of deep papers on it. In fact, there's something that I studied as I was an undergrad studying a little bit, which nowadays seems trivial because that was decades ago. But in any case, yeah. But the more straightforward way is that if you're giving one use, one convocation, one thing, right? Then all you have to do. Sorry, my thing is a little dirty. All you have to do is just walk the tree, right? There are a number of ways you can do it. I think you can just walk one node and then the other one look up on a lookup table. It is worst case complexity O of n, but that's okay, I think, right? Yeah. Otherwise, yeah, I think that's mostly the idea if you don't want to pre-process the tree. The key thing to note is that for this particular one, you are given the parent node, which makes things a lot easier, honestly, right? Because then now we can say, well, I actually wonder what if the root is parent none so parent node makes it easy, but I want to say that if it is root, then there's none. But I don't know. Let's see if this is right, because it's not clear. It's not. So you want something like this. Maybe, you probably should actually, okay, fine, right? So maybe PC for a copy of, and keep in mind that these are references, so you're able to do this way. And then, yeah, and then you go PC dot, are we returning the node? Okay, yeah, so then we just kind of say, yeah, we just have a set is your set, scene dot add PC, and that would be good. And then now, we just do copy of Q while QC is not none and QC is not in scene, right? Then QC is equal to QC dot parent, and then now that means that either QC is none or QC is not in. Well, QC cannot be none if they're both in the same tree, but if that means that QC is in scene, that means that this is the lowest common ancestor, and you could just return it. I think that's I'm misunderstanding this problem. Not in scene. Oh, it's not in scene. Too much English because I was looking at the other thing. All right, let's give it a submit. And yeah, and that's pretty much it. What's the complexity, right? This is going to be linear time, linear space. You can imagine that you have basically a long tree where it's two linked lists connected to each other or something like that. And yeah, that is all I have for this one. Let me know what you think. Thanks for watching. Give some support doing this for, but I did this very quickly, so it's fine. But yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.